Hello. So hopefully you have done some sort of discovery or interactive thing to think about the sides of a triangle, like what the measurements could be, what's possible to create a triangle. So here's this presentation. We can call this the triangle inequality. So the applet that you're playing with prompts you with questions like this, like could you make a triangle with the sides 4, 5, and 10? And if you tried, you would fail. Oh, I have to plug this up. Because you have this longer side of 10. Let me see if this writes. Whoop. Ah, my shadow's in the way. Of 10. And then this one's 4, and this one's 5, and they don't quite line up. Like they don't even add more to 10. Like this blue one would be here, and the red one, the green one would be here, and it just doesn't add up. It can't form a triangle. That one side is just too big. So it should ask you what your thoughts are on what the sides need to be. But let's formalize it and write down the triangle inequality theorem. So the sum of the lengths of any two sides of a triangle, okay, so the sum of the lengths, you have two sides and you add them together, and it needs to be greater than the length of the third side is greater than. Greater than. So if you have a triangle with side 1, side 2, side 3, let me connect that. So if I took the red side, that green plus the blue needs to be bigger than that third side in order for that to be able to make a triangle. Like in the last example with the 10 and the 4 and the 5, it's just not enough. Then you can't meet the two endpoints. You can't form a triangle. So that's your triangle inequality theorem. So the types of questions that you get are checking if three sides are possible. So for example, we have 3, 3, and 6. Well, you have to check every different combination of 2. So 3 and 6, is that greater than 3? You bet. But we have a problem here. These two, the sum of these two is not greater than. Now remember, I didn't say greater than or equal to, I said greater than. So and to prove it, 3 plus 3 is not greater than, so I'm putting the greater than symbol with a line through it, 6. So this is not possible. Not a possible side length. And if we wanted to do a little sketch, we would have the longest side of 6, and then 3 and 3, and they just wouldn't be able to match up. They have to be a sum greater. If you had 3.05 and 3, that would have worked. But it's not strictly greater than 6. What? We have a guest for B.
Hello. So 4, 2, and 5. So we got to try all 3 again. So if you try the first 2, 4 plus 2 is greater than 5 because it's 6. And then 2 and 5 is greater than 4 because it's 7. And 7 is greater than 4. And then 4 and 5 is greater than 2 because it's 9. So in that case, it works because each pair of sides is bigger than the third side, and you get a triangle.
Well put. Thank you, celebrity guest. For C, this is going to work also because if you add these two together, it's greater than 5.2, and any combination you do, it will work. And we actually know what type of triangle this is. This is equilateral. So that's okay. That'll work out. So just notice how you justify. You have to add up two sides and see whether it's greater than the third, and you have to show either every combination, like all 3, or just show one that contradicts it and makes it not possible. Okay, so I'm going to have you try one now. And Edpuzzle will ask you a question to enter. The second type of example is this. So it gives you two sides of a triangle, so 9 centimeters and 4 centimeters. And it wants you to list, possibilities for the third side. possible integers. So integers are positive and negative whole numbers. But actually, we're never going to have negative sides. So just realize that that's numbers like -2, -1, 0, 1, 2, 3, 4, etc. So we're just going to list those. We're not going to say like it can be 5.7. We're just going to say integers. Okay, so I'm going to do this kind of a complicated way and then show you a shortcut. So I know, let's say I call this third side x. So I know if I combine 4, 9, and x, like any two combinations need to be greater than the third. So if I have the sum of 4 and my unknown side, it has to be greater than 9. Right? Two sides have to be greater than the third. Two sides have to be greater than the third. And then what's my last combination? Two sides have to be greater than the third. So I took every combination of the two sides, 4 and x, 4 and 9, and x and 9. And I set up these three inequalities because they all need to be satisfied. Okay, so for this one, it becomes, if I subtract 4, x has to be greater than 5. And then for the bottom one, okay, this one's kind of trash because you get x has to be greater than -5. So I'm actually going to, this is trash. Trash. Of course it's going to be greater than -5. It's going to be a side length. But we're going to get other good information from this one because this says x has to be less than 13. X has to be less than 13. And now I'm going to take these two statements and interpret it as like a between. So x has to be greater than 5 and less than 13. So x has to be between 5 and 13. Now notice x cannot equal 5. I can't have 9, 4, and 5 as a possible combination because 4 plus 5 is not bigger than 9 it's equal to. So notice how this is these are non-inclusive symbols. So I'm not saying 5 is an option. I'm saying up to 5 is an option. So my possible integer measures would be 6, 7, 8, 9, 10, 11, and 12. And notice how I don't include 13 and I don't include 6. And so this is the final answer, these values. So any combination of like 6 and 4 and 9, any combination of 2 will be greater than the third. Okay, let's see another example. Okay, so this time it gives me two sides, 11 and 6. What is the range? Okay, so it gives me the range. It doesn't say like list integer stuff. It just wants the range. So I know if I call the third side x, I'm going to think about every combination of the two. So I can put x and 11 together. I can put x and 6 together, and I can put 6 and 11 together. And I know it always has to be greater than the third. So this would be greater than 6, this would be greater than 11, this would be greater than x. And then if I simplify these inequalities, x has to be, okay, this one's the trash one because I get -5. That's going to be a given. This one, x has to be greater than +5. And this one, let's see, this becomes 17 is greater than x. So that's written as x is less than 17. Okay, so remember, this one's trash. And now I want to interpret these two. So what's x between? Well, it has to be greater than 5 and less than 17. So this would be your answer. This is the interval. That in interval notation, we would say we go from 5 to 17. So that's not a coordinate, but an interval, where 5's the smallest value, or like not including 5, but like 5.01, smaller bound. And this is your bigger bound for an interval. It's not a coordinate. I think you did this in Algebra 1, so you should be okay. bigger bound. So that's your range. Now, you're probably thinking, didn't you say there was a shortcut? Yeah, there is. So the two numbers were 11 and 6. So what you can do is just add them together, and that's like the upper bound. So like x could be 16.9999, but it can't be up, like can't be exactly 17. So it can be up to 17. It has to be less than 17 if you add them together. And then if you subtract them, it has to be greater than 5. So you might have noticed that already. So if you don't really have to set up these inequalities. You can just add the numbers. That's going to be like add 11, 6. That's going to be your upper bound. Subtract the larger minus the smaller, get the lower bound. Just make sure you really realize that those are non-inclusive symbols. Like it can't be 5. It can't be 5. It can't be 17. It can only be the things between 5 and 17. Okay, so Edpuzzle should ask you to do a couple practice. Go back, watch it, do it again, ask the questions, and this is the end. Oh, has it been recording?